Hello and welcome to another one of these ADD videos. Today we're going to be looking at some examples dealing with trig functions. So a couple scenarios may occur. One in which you're given information about a couple of the trig functions and you're asked to find all 6 trig functions based off of that. Or you might be given a terminal leg going through a point scenario, and we're going to go through those today. So let's look at these type first. What you got going on here is you're given that sine is 2/5. So automatically you know that cosecant is the reciprocal of 5/2. Now to get the other ones, what you got to do is you got to figure out what quadrant you're in. Use Pythagorean theorem to figure out the missing leg. So let's go ahead and do that off to the side. So we got sine is opposite over hypotenuse. So we know it's going to be 2 squared plus missing leg squared equals 5 squared. So that's 25 minus 4 is b is going to be equal to the square root of 21. It's possible to have a plus or a minus in these. So in this case, which one is it going to be? Is it going to be the plus or the minus? Well, let's figure out what quadrant we're in, and that will tell us. So if I were to use my little acronym that tells me what trigonometric function is positive in what quadrant, I remember that all students take calculus. So that's all in this one: sine and cosecant, tan and cotangent, cosine and secant. If this is not familiar to you, just go back to the trig functions concept video. So here we have sine is positive. Well, where's sine positive? It's positive in this quadrant and in that quadrant. Okay. What else do we know? Well, right here it tells us that cosine theta is negative. Well, cosine is negative in what 2 quadrants? Well, since it's positive in the first and the fourth, it would be negative in the third and the second. So which one of these has 2 check marks? The second quadrant. So what you do then is you use your triangle in the second quadrant. Always connect with the x-axis, never the y again. Same thing with the reference angles, right? Sorry about that. It's supposed to be perpendicular, right? So that we can form a right triangle and use your right triangle geometry. All right, so here's your theta. And we know that sine is opposite over hypotenuse. We just figure out the missing leg was this, and it's in the negative x direction, right? X goes positive that way and negative that way, so it would be the negative of the 2 roots, okay? All right, so now that you have that, you can find the missing trig functions. Let's see if we can squeeze them in there. If I want cosine, that's adjacent leg over the hypotenuse. Remember SOHCAHTOA? So cosine is adjacent over hypotenuse, and then that's going to be a negative root 21 over 5. So then secant theta would be its reciprocal, negative 5 over root 21, multiplied by root 21 over root 21, and you're going to get sorry about that. Okay, and tangent is the only one left, so tangent's opposite over adjacent. So that'd be 2 over negative root 21, or negative. And when you rationalize, you get negative 2 over 21. And finally, cotangent would be the reciprocal. And instead of doing this one, it'd be easier to just flip this one here before we rationalized it. So negative root 21 over 2. Okay? So what were my steps? Well, I first found the missing leg using Pythagorean theorem. And since sine here is opposite leg over hypotenuse, this is one leg, this is the other leg that's missing, and it's always equal to the hypotenuse squared when you square the sum of the legs. Then you just solve for the missing leg, square root both sides, and then ask yourself, what quadrant are you in? How did I know what quadrant? Well, sine is positive, according to this, and cosine is negative. That only occurs in the second quadrant, if you go through your little acronym. And then after that, then you're going to choose the appropriate positive or negative root of that b. In this case, it has to be negative because this is in the negative x direction. Had it been in this quadrant, that would be in positive x direction, so that would have been a positive root 21. Okay? And just use your SOHCAHTOA, find the missing leg. So in this case, if you did this problem, you should have gotten those right away. Sorry about that. There's your cosine. There's your secant. There's your tan. And there's your cotan. Okay? Let's look at another one. I'm going to go a little bit faster on this one. So we have sorry, I'm adjusting my size of the marker from highlighter mode to normal writing mode. So we have cosine, which is the adjacent leg over the hypotenuse. So we got negative root 5 squared plus 6, b squared, the missing leg, equals 6 squared. So we got 5, because negative root 5 times negative root 5, the two negatives become a positive, and square root of anything times the square root of itself is that thing underneath the square root. So we have b squared equals 36. Subtract, you get b squared equals 31. So b equals plus or minus 30, root 31. So let's figure out what quadrant we're in. Where is tangent positive and yet cosine's negative? Well, tangent's positive in the first one, they're all positive. Take is in the third quadrant. And then cosine's negative in this quadrant here and this quadrant there, because it's positive in these two. So as a result, we know we're in the third quadrant, so let's draw our triangle. So when I draw the triangle, I am going to use the x-axis always. And we know the hypotenuse is 6. And the hypotenuse is always positive. And then we know that the adjacent leg is negative root 5. And then, is this going to be the positive or the negative root 31? Well, in order for tangent to be positive, it'd have to be the negative root 31, right? Or another way to look at it is it's going in the negative y direction. So it has to be negative root 31. Okay? So now just do your SOHCAHTOA. Sine theta is going to be the tangents, the negatives cancel out, and you got to rationalize it, get rid of that root 5 on the bottom. So it's going to give you a 5, 15, right? So 155 under the square root, sorry, over 5. And then take the reciprocals for their counterparts here. We got cosecant theta is going to be -6 over root 31. Notice the negative sign just can flip up top. Do a little rationalizing. Some professors don't care about rationalizing. It's going to be punched into the calculator anyway. I seem to agree, but others are picky, so just practice. If you don't have the hang of rationalizing, it's not too bad. So we have secant theta is going to be -6 over 5, which then, after we rationalize, it's going to be -6 root 5 over 5, and then tangent if I flip that one, remember the negatives canceled. So those would be your answers there, and I'll highlight them just so you can see them. Those of you that are actually pausing the example videos and trying them on your own, that's the way you should be doing these. Okay, don't just watch me do them. It doesn't do you as much good as actually going through and trying these. Okay. All right, let's try this last one here. So we have cosecant theta. Hopefully you can see that before the rationalization it was 4 over root 3. So when I flip it, it would be root 3 over 4. And then if I did that, if I flipped it, it wouldn't be cosecant. What would it be? It would be its reciprocal sine. And then that's my opposite leg, that's my adjacent leg. So if I do the Pythagorean theorem, that would be 3 plus b squared equals 16. B squared equals 13. B equals plus or minus root 13. Again, we need to figure out what quadrant we're in. So in this case, we know cosines or cosecant is positive in that one and in that one, and cosine is positive in that one and that one. Is that right? So sine on top 2, cosine. Yep. So we're in the first quadrant, it looks like. So in this case, in the first quadrant, they can both be positive. That's supposed to be a straight axis right there. Let's try that again. So in this case, we have root 3 is the opposite leg. Let me draw my triangle. So the opposite leg is root 3, the hypotenuse is 4, and since it's positive, I choose the positive root of 13. And then just do SOHCAHTOA again. Hopefully you've got the hang of this by now. This video's taken a little bit longer than I would have liked it to, but that's fine. So that would be root 13 over 4. Tangent theta would be root 3 over root 13, which when you rationalize that, you can check my work if you want to. It would be root 39 over 13. And then when I flip it, it's going to be 4 root 3 over 3. And it's going to be root 13 over 13, and just flip that and rationalize it. So I'll write that up here since I have no room for cotangent. So it'd be root 13 over 3, root 3, sorry, and then when you rationalize it, that would be a 39 there. Sorry. Okay, so hopefully you've understood these. I'm going to make another video for the terminal point ones because otherwise this would be too lengthy a video, not too ADD if it's 20 minutes long. So let's go ahead and stop here as a good stopping point. Hopefully you got these right. If not, you need to practice, okay? That's the best way to get better at these. I hope this has cleared up some confusion you might have. Thank you and have a nice day.